Hello everyone, so here we shall start from question number 19 onwards. So in the previous part of this video on current electricity, we had solved till question number 18. We shall start in this part 2 from question number 19 onwards. So if you are unable to understand any steps or any other doubts you have, then please write that in the comments section. Okay, so let's start. So it is told that B1, B2 and B3 are the three identical bulbs connected to a battery of steady EMF with key K closed. What happens to the brightness of the bulbs B1 and B2 when the key is opened? Three identical bulbs, they are connected to a battery steady EMF. So this battery is there, it provides a steady EMF E. Key K is closed, and B3 bulb, this is there, and this is B2. Okay. What happens to the brightness of the bulb when key K is opened? When key K is opened, then B1 and B2 bulbs will continue to glow since current will flow through them. But B3 through B3 no current will pass. So it means that the effective resistance that will increase. So now higher effective resistance, so now lower current will flow. It means that when key is opened, then more current will pass through B2, but lesser current will pass through B1. So it means that the brightness of B1 will decrease, the brightness of B2 will increase. Since why lesser current will pass through B1 when key K is opened, lesser current will pass through this B1, and through B2 the current will increase. It means that brightness of bulb B1 decreases and that of B2 increases. So option C is the correct answer. Then it is told in the circuit shown the currents I1 and I2 are. So here the equivalent resistance in the circuit R equivalent, that will be equal to, so 12 and 4 are connected in parallel, so their equivalent is 12 into 4 by 12 plus 4, that is 16, and plus 2 plus 1. Since 1 ohm is the internal resistance of the cell, so this will be 4 4 is 16, 4 3 are 12, so 3 plus 3, that is 6, or equivalent 6, and then so current, so the total current I1 plus I2, that will be equal to V by R, so that is 12 by 6, that is 2 ampere. So now I1 will be equal to, so now that is, so it will be, current will be divided in the inverse ratio of the resistances. So this will be 4 by 16 into 2 ampere, so that is 4 4 is 16, so 2 to the 4, that is half ampere, 0.5 ampere I1, and I2 will be equal to 2 minus 0.5 ampere, that is 1.5 ampere. I1 is 0.5, I2 is 1.5, so option B is the correct answer. Then in question number 21 it is told a conductor where having 10 power 29 free electrons per meter cube. So n is equal to 10 power 29, which is the number density of electrons, and it carries a current I which is 20 ampere. If the cross section of the wire A, that is 1 millimeter square, then the drift velocity of electrons will be. Drift velocity of electrons, the area of cross section, area of cross section of the wire, that is 1 millimeter square. So 1 millimeter is 10 power minus 3 meter, its whole square. It is 10 power minus 6 meter square. Then the drift velocity will be equal to how much? And the charge on the electron is 1.6 into 10 power minus 19 coulomb. So we know that I is equal to NEAVD. So that is, therefore, the drift velocity is asked. So that is I by NEA, which is I is 20 ampere, N is 10 power 29, E is 1.6 into 10 power minus 19, and A is 10 power minus 6. So this will be 20 by, will be 16 into 10 power minus 1. So this is 10 power 29 minus 20 minus 6. This will be 10 power 3. So 20 by 16 into 10 power 3. This will be 4 4 the 16, 4 5 the 20. So 5 by 4 is 1 the 4, 1.25 to 10 power minus 3 meter per second. So this is the drift velocity. So option B is the correct answer. Then in question number 22, it is told a resistor has a color code of green, blue, brown, and silver. What is its resistance? So the rule is that we know that dB, so blue, it is brown, black, and then red, orange, yellow, green, and then blue, violet, then green, and then gray, and white. Silver. So for this, for brown it is 1, it's 2, this is 3, for red this is 3, orange 4, 5, 6. So this is called as the color code of resistors. Color code of resistors. It is blue 7, 8, 9. Then what this is 10%. 0. Okay. Then for white it is 5%. Then the color code is given. First is green, and then blue, green and then blue, and then brown, and then silver. So this is the color code of the resistor. So therefore its resistance is green is 6, blue green is actually 5. First is black and then it is brown. Okay. 0, 1, 2, 4, 5, 6, 7, 8, 9. Okay. So for brown, for green it is 5, and for blue 6. So, and then for brown is 1. 56 into 10 power 1 plus or minus for the silver it is 10%. So this is 560 plus or minus 10%. So 560 ohm plus or minus 10%. So option B is the correct answer. So the voltage V and current I graphs for a conductor at two different temperatures T1 and T2 are shown in the figure. Relation. So the voltage VI graphs. So this is VI graph. This is given. This is for T1 and this is for T2 actually. This was in the question. So VI graph. So we know that the slope of V versus I graph. Slope of V versus I graph is, it gives the resistance. Gives the resistance. So slope is R. The relation between T1 and T2 is, so here we can see that the slope is higher in case of the first one. Here the resistance is R1 and this is, so here, so R1 is obviously greater than R2 since the slope is higher. So therefore it means with temperature the resistance increases. When temperature increases, resistance also increases. It means that T1 is greater than T2. And A is the correct answer. Question number 24, it is told, consider the following statements regarding the network shown in the figure. Now it is a Wheatstone bridge. The equivalent resistance of the network between points A and B, that will be, this is equivalently, this is 2R, they are in series. This 2R and 2R, that is 4R are in series. So the equivalent resistance is 2R into 4R by 6R. That will be R will cancel to 1, 2, 3, 6. So this is 4R by 3. Okay, so there is equivalent resistance of network between points A and B is independent of the value of G here. That is correct. So option 1, so the first statement is correct, and the equivalent resistance of the network between points A and B is 4R by 3. So second statement is also correct. The current through G is 0, that is also correct. So 1, 2 and 3, option D is the correct answer. 25 is, which of the following graphs correctly represents the variation of heat energy produced in a metallic conductor in a given time as a function of the potential difference across the conductor. Variation of heat energy that is produced in a conductor as a function of potential difference in a given time. So that is V square by R into T. So U is proportional to V square. U is proportional. That means that U is proportional to V square. It means that it is of the form Y is proportional to X square. It means that the graph should be like this, versus V. It means that option D is the correct answer. Since Y, it should be having the graph should have a parabolic shape. Graph should be having a parabolic shape. Question number 26 is, current of 2 ampere is passed through a metallic wire. Current of 2 ampere is passed. The area of cross section is 2 into 10 power minus 6 meter square. The number density of electrons in the wire is 5 into 10 power 26 per meter cube. The drift speed of the electron is the drift speed Vd. That is how much? The drift speed of the electrons that is given by. So I is equal to NEA Vd. So Vd we have to find drift speed, that is equal to I by NEA. So that will be equal to 5. So that is 2 ampere divided by N is 5 into 10 power 28, and E is the charge on the electron, that is 1.6 into 10 power minus 19, into area of cross section, that is 2 into 10 power minus 6. So 2 and 2 will get cancelled. This much meter per second. So this will be 1 by 16 5 is 80. So this will be 8. 8 into 10 power 28 minus 19 minus 6. This will be, so 28 minus 6 is 22. 22 minus 19 is 3. It's 1 by 8 into 10 power 3. So this is speed or density. This is not 10 power, so this is 10 power 26. Sorry, there's something wrong. Speed is 6. So 26 minus 6, that is 20. 20 minus 19 is 20 minus 19 is 1. So 1 by 80. 1 by 80 meter per second. Option C is the correct answer. Question number 27, it is told, in this circuit when certain current flows, the heat produced in 5 ohm, heat produced in the 5 ohm resistor, this is 6 ohm, this is 9 ohm, this is 5 ohm. Certain current flow, heat produced in 5 ohm is 4.05 joule at time t. The current, certain current flows, the heat produced in 5 ohm resistor heat produced Q, that is equal to 4.05 joule in time t. The heat produced in 2 ohm coil, the same time interval is. So the fact is how much current will pass through it. Let's say I current is flowing. So then here this is 15 ohm, this is also 5 ohm. So current will be divided in the inverse ratio of resistances. So through this, if I1 current is flowing, through this I2 current is flowing, then I1 will be equal to 15 by 5 plus 15 into I1. That will be 15 by 20 into I1, that is 5 is 15, 5 4 is 20, so 3 I1 by 3 I by 4 actually, 3 I by 4, and so I2 will be equal to I minus I1, that is I minus 3 I by 4, that is equal to I by 4. So through this I by 4 current is flowing, and through this 3 I by 4 current is flowing. Now therefore the heat produced in time t, that will be equal to I square R into t. It means, and that is given as 4.05. Means that 9 5 9 are 45, 45 by 16, 45 by 16 I square into T, that is given as 4.05. So it means that how much heat will be produced in the 2 ohm resistor. So let's say that is Q1. So that will be I square into 2 into T. That will be 2 into I square T. This will be 2 into, now I square T will be, from here we can find the value of that. That is 4.05 into 16 by 45. So this will be also 4.05 into 16 by 45. So I can cancel with 45, we can cancel with 90, that is with 9. 5 nines are 45, 9, 4 nines are 36, 5 nines are 45. So then again 5 nines are 45. This is 2 6 are 32, 32 into 0.09. That will be 9 to the 18, 9 to the 18, 327, 28, so 2.88 Joule. So option C is the correct answer. So in this circuit, the value of I2 is given as 10 ohm, this is I1, this is I2, this is 15 ohm, this is I3, this is 1.2 ampere. Circuit, the value of I2 is given as I2, that will be equal to, now it is, current will be divided in the inverse ratio of resistances. Therefore, I1 is to I2 is to I3. That will be equal to 1 by 10 is to 1 by 15 is to 1 by 30. That will be, so I can multiply with 30, so this will be 3 is to 2 is to 1. So therefore, I2 will be equal to 2 by 3 plus 2 plus 1 into the total current, which is 1.2. So this is 2 by 6, 1.2. So 6 2s are 12, 0.4 ampere. So option C is the correct answer. Question number 29, it is told copper and germanium are cooled from room temperature to 100 Kelvin. Then the resistance of, so for germanium, the resistance, okay. So now the temperature, we know that alpha which is 1 by r dr by dt, which is called as the temperature coefficient of resistance. Temperature coefficient of resistance. So now that alpha is negative. Alpha is negative for germanium, and alpha is having positive value for copper. So it means that as temperature increases, the resistance of copper increases, but when temperature increases, the resistance of germanium decreases. So it means that we can say in the reverse order. Here it is cooled down from room temperature to 100 Kelvin. So when temperature will decrease, the resistance of copper will also decrease. But if temperature is decreased, resistance of germanium will increase. So it means that the resistance of germanium increases and for copper it decreases. Option C is the correct answer. In the circuit, here it is told, question number 30, in the circuit diagram, heat produced in R, 2R and 1.5R in the ratio. So suppose I current is flowing, Now this is R resistance and this is 2R resistance and this is 1.5 R resistance. Now I current is flowing, then how much current will pass through this? Let's suppose it is I1. So I1 will be equal to 2R by 2R plus R, that is 3R, into I, that is 2I by 3. So here 2I by 3 current will pass. Now it means through 2R I by 3 current will pass. Through 1.5R I current will pass. So therefore the heat produced in the resistance R, let's say that is Q1. Resistance, the heat produced in the resistance 2R is suppose Q2, and heat produced in the resistance 1.5R, that is Q3. Q1 is to Q2, we have to find Q1 is to Q2 is to Q3. Q1 will be equal to I square, which is, so through R resistance 2I by 3 current will pass. So 2I by 3 whole square to R is to, this will be I by 3 whole square into 2R, and is to, this is 1.5 R, this is 3 by 2 R, 3R by 2 R into I square. So this will be like 4I square by 9 into R is to, this is 2I square R by 9 is to, this is 3 by 2 I square R. I square R, I square R, I square R will cancel. Then we can multiply with the LCM, that is 2 9s are 18. We can multiply with 9, so this will be 4 is to 2 is to 3 by 2 is to 9, to 9, 3 9 is 27 by 2. So this will be, again we can multiply with 2, this will be 8 is to 27. So option B is the correct answer. Then question number 31 is told, a carbon film resistor has color code green, black, violet, gold. Green, black, and then violet, and then for gold it is 80, it is 5%. Gold it is 80, it is 5%. Okay. Since we know that that is black, black, brown, black, brown, then red. This is the color code of resistors: black, brown, red, orange, yellow, green, then violet, then gray, white, silver, and gold. So for black, the resistance value is 1. Oh, sorry, this is 0, this is 1, this is 2, 3, this is 4, this is 5, this is 6, this is 7, this is 8, 9. And here we have, this is 10%, this is 5%. So these are delta R and these are R values. So it is the error. This is the percentage error, the resistance. So if the color code is green, green, blue, green, black, sorry, green, black, violet, gold. Green, black, violet, gold. So green is 5. Green is 5 and black is 0 into 10 raised to, violet is 7, so 10 raised to 7, 10 raised to 7 plus or this much ohm plus or minus gold is 5%. So this is the value of the resistance. We can say it is 500 into 10 power 6, so 500 mega ohm plus or minus 5%. Option A is the correct answer. Since why here we can see that 1 mega ohm is equal to 10 power 6 ohm. So 15 to 10 power 7 I can write 500. This I can write 500 into 10 power 6 also. Question number 32, it is told two resistors of resistances 2 ohm and 6 ohm are connected in parallel. So So this is 2 ohm, this is 6 ohm, are connected in parallel. Then this combination is connected a battery. This combination is connected to a battery EMF, EMF 2 volt, and internal resistance 0.5 ohm. What is the current flowing through the battery? Current flowing through the battery is how much? That we have to find. So current flowing, so this equivalent resistance will come to 6, that is 8. So 3 by 2, that is 1.5. So therefore R equivalent, the equivalent resistance in the circuit is 1.5 ohm plus 5 ohm, that is 2 ohm. Therefore the current is E by R equivalent, that is 2 volt by 2 1 ampere. So option C is the correct answer. Question number 33, it is told the equivalent resistance of two resistors which are connected in series, R1 and R2, is, so R1 plus R2 is 6, and their parallel equivalent resistance. So when they are connected in parallel, R1 and R2, then their equivalent resistance will be, R equivalent is R1 R2 by R1 plus R2, that is 4 by 3 ohm. Then the values of the resistances are. So therefore it means that R1 by R1 R2 by R1 plus R2 is 6, so that is equal to 4 by 3. So that R1 R2 will be equal to 4 by 3 into 6. 3 to 6, that's 8. R1 R2 is 8. Therefore R1 minus R2 whole square, that is equal to R1 plus R2 whole square minus 4 R1 R2. So therefore R1 minus R2 square, that will be equal to 6 square minus 4 into 8. So 36 minus 32, so that is 4. Means R1 minus R2, that will be equal to 2. R1 minus R2 is 2 and R1 plus R2 is 6. So therefore I can, so if we add them, then we'll get 2 R1, that is equal to R1 is 4. R1 is 4, it means that R2 is 6. Sorry, R2 is 2 ohm. So R1 is, so one is 4 ohm and one is 2 ohm. Option A is the correct answer. Then question number 34 is, in a potentiometer experiment of a cell, in a potentiometer experiment of a cell of EMF 1.2 volt gives balancing length of 30 centimeter. Balancing length of 36 centimeter. So the EMF here, balancing length. So let's say here, this is the balancing length. This is the balancing length, which is 30 centimeters. So in the potentiometer where there is a voltage drop per unit length, so let's say it is 5. 5 is equal to R by L, R naught by R by L, suppose here, which is the resistance per unit length of the potentiometer where the cell is replaced by another cell. So E is equal to 1.25 volt. Then the balancing length is 30 centimeter. If the cell is replaced by another cell, balancing length is found to be 40 centimeter. What is the EMF of the second cell? So phi is the voltage drop, or yeah, this is V by L. So this is V by L actually. So this is the voltage drop per unit length in the potentiometer where. Voltage drop per unit length in the potentiometer where. Potentiometer where. Now Therefore, E is equal to 30 centimeter, 30 centimeter into 5, and when it is replaced by another cell, then the new EMF is E1, suppose. So E1 is 20 centimeter, so 40 centimeter into 5. So therefore, from here we can find out phi. Phi is equal to 1.25 volt by 30 centimeter. Phi is 1.25 by 30 volt per centimeter. So therefore E1 will be 40 into 1.25 by 30, this much volts. So 0 will cancel. So this will be, is the 20, 4 to the 8, 10, so 4, 5 by 3. So 5 by 3 volt. 5 by 3 volt is approximately 3 ones are 3, 2 by 3 is 1.67 volts. So option D is the correct answer. The resistance of the bulb filament is 100 ohm at a temperature of 100 degrees Celsius. Resistance of the bulb filament is 100 ohm at a temperature of Celsius. With temperature coefficient of resistance be 0.005 per degree Celsius, resistance will become 200 ohm at a temperature of this much. So the resistance of a bulb filament, the resistance is given as 100 ohm at temperature T is 100 degrees Celsius. Its temperature coefficient of resistance is 0.005 per degree Celsius. Its resistance will become 200 ohm at a temperature how much? The resistance R1, that is equal to 200 ohm at T1 equal to how much? Okay. So now let's say R0 is the temperature at 0 degree Celsius. Now therefore we know that RT, that is equal to R0 into 1 plus alpha delta theta. No, alpha delta T. Where R0 is the R0 is the resistance at 0 degree Celsius. R0 is the resistance at 0 degree Celsius, and alpha is the temperature coefficient of resistance, that is 0.005 per degree Celsius, and delta T is T minus is 0 degree Celsius. So I can take it as T only. So therefore here, and RT is the temperature at T degree Celsius. RT is the temperature, RT is the resistance, RT is the resistance of the bulb filament at T degree Celsius. Okay, so therefore here it is told is 100 ohm at, this is R0 into 100 will be equal to R0 into 0.005 into T, that is 100. So 100 into this, it will be 0.5. So therefore R0 into 1.5, 0.5, so that is equal to 100. Therefore R0 will be equal to 100 by 1.5, so 15 by 10. So 5 3 are 15, 5 2 are 10, so this is 200 by 3. R0 is 200 by 3 ohm. Now therefore we have to find the temperature at which the resistance is 200 ohm. So that will be 200, that is equal to R0, which is 200 by 3 into 1 plus 0.005 into T1. So therefore I can say 200 will cancel. So this will be 1 plus 0.005 into T1, that is equal to 3. So therefore 0.005 into T1, that is equal to 2. So therefore T1 will be equal to 2 by 0.005 is equal to 2 by 5 by 1000. This is 5 2s are 10, 200. So this is 400 degrees Celsius. So option A is the correct answer. Then in question number 36 it is told, in a Wheatstone network P is 2 ohm, Q, this is P, this is Q. Q is 2 ohm, and R, sorry, this is Q, this is 2 ohm, and R is also 2 ohm. Q, RS, and S is 3 ohm. The resistance with which S is to be shunted, it should be shunted with another resistance, say R1, in order that the bridge may be balanced. So it means that this equivalent resistance should be 2 ohm. So therefore the equivalent R equivalent should be equal to 2 ohm, which means that this S into R1 by, they are connected in parallel. So this will be S into R1 by S plus R1, that is equal to 2. Therefore S is 3. So 3 into R1 by 3 plus R1, that should be equal to 2. Or we can say that this will be like 1 by 3 plus 1 by R1. 1 by 3 plus 1 by R1, that should be equal to 1 by 2. That 1 by R1 should be equal to half minus 1 by 3, that is equal to 3 to the 6, 3 minus 1, 3 minus 2, 3 minus 2, that is 1. So R1 should be equal to 6, so it should be 6 ohm. 6 ohm should be connected. Option B is the correct answer. Three resistances 2 ohm, 3 ohm and 4 ohm are connected in parallel. They are connected in parallel. 3 ohm, 2 ohm, 3 ohm and 4 ohm connected in parallel. The ratio of currents passing through them when a potential difference is applied across its ends. How much current pass through them? The ratio of currents passing through them when a potential difference is applied. Okay. So the ratio of the currents I1, I2 and so I can see, yeah. So I1 is to I2 is to I3. So through 2 ohm I1 current is flowing, 3 ohm I2 current is flowing, through 4 ohm suppose I3 current is flowing. I1 is to I2 is to I3, that will be equal to V by R. V by R is to V by 3 is to V by 4. So this is 1 by 2 is to 1 by 3 is to 1 by 4. We can multiply with 12, it will be 6 is to 3. So option A is the correct answer. In question number 38, it is told 4 identical cells of EMF E and internal resistance R. 4 identical cells to be connected in series. So this is having EMF E and resistance R, and 4 of them. 4 cells are connected in series. Suppose if one of the cell is connected wrongly, the equivalent EMF and effective internal resistance in the combination is, one of the cell is connected wrongly. The equivalent EMF and equivalent and the effective internal resistance are effective. It means that one cell is connected wrongly. Let's suppose the second cell is connected wrongly like this. E are for resistance. So their equivalent EMF that will be equal to E plus E plus E, but this is this is connected wrongly, so it is in the opposite sense, connected in the opposite direction, so it will be minus E. This will be 2, and R equivalent will be equal to 2E and 4R. Option D is the correct answer. Question number 39. The circuit shown below, the ammeter and the voltmeter readings are 3 ampere and 6 volt respectively, and the value of the resistance is. So the voltage is 6 volt. So R equal to V by I. 6 volt divided by 3 ampere. This is 2 ohm. Actually, the ammeter also will have some resistance in it. will have some resistance. So the ammeter also can have some resistance R1 in it, R, and the voltmeter also can have some internal resistance in it, say R2. So therefore, here through this current flowing is 3 ampere, and so sorry, through this 3 ampere current is flowing, and across 2.6 volt is there, 6 volt. So therefore 3 ampere, 3 into R1 plus R2, I into R equivalent means I into R, into R. This R equivalent, R1 and R are connected in series, so their R equivalent is R1 plus R. So R1 plus R, sorry, 3 ampere current is flowing, so R I into R1 plus R, that is equal to 6 volt. V equal to, therefore R1 plus R, that is equal to 2. R should be equal to 2 minus R1. It means that R should be less than 2. Option D is the correct answer. It means that if the ammeter has some finite resistance in it, it means that the value of this resistance will be slightly less than 2 ohm. And question number 40 is told two cells of EMF E1 and E2 are joined in opposition such that E1 is greater than E2. If R1 and R2 be the internal resistance and R be the external resistance, then the terminal potential difference is how much? The terminal potential difference will be, let's say here this is R1, E1, this is E2, this is R2, and this is external resistance R. Okay. So let's suppose this point, the electric potential at this point we take it as VA, and the electric potential at this point we take it as VB. So if we apply KVL, then we will get current. So E1 is greater than E2, so current is flowing in this direction. Current is flowing in this direction, since the first cell will dominate over the second cell. Since why? Second, this EMF is higher, so first cell will dominate. First cell will dominate. It means that the current will pass like this. So the E equivalent is actually E1 minus E2. So it will be VA then plus I into R1. So here how much will be the current? R equivalent is R1 plus R2 plus R, and E equivalent is E1 minus E2. So therefore, how much current will flow? I through the current through the circuit, that will be E equivalent by R equivalent. That will be equal to E1 minus E2 by R1 plus R2 plus R, and therefore the terminal potential difference VA minus IR, that is equal to VB, means that VA minus VB, that is obviously equal to IR. I into R, that's what I can do. So therefore the terminal potential difference VA minus VB, that is E1 minus E2 by R1 plus R2 plus R into R. That means that option B is the correct answer. Question number 41, it is told a capacitor of 8 farad is connected as shown. Capacitor of 8 farad is connected as shown. Charge on the plates of the capacitor is. So when it will be completely charged, then no current will flow through this. That means then the potential difference across the capacitor, that will be same as the potential difference across this 4 ohm resistor. So through this no current will pass, so the equivalent circuit will be only this part. So therefore the current which will flow after it gets fully charged, the current that will flow through this part when the capacitor gets fully charged, that will be equal to given as 5 volt by this 5 ohm, that will be 1 ampere. 1 ampere current will flow. So the potential difference across this 4 ohm resistor, that is V1 suppose, that is equal to I into R, is equal to 1 ampere into 4, that is 4 volt. Therefore 8 farad. So therefore the charge on the plates of the capacitor Q, that will be equal to CV, C into V1, that is equal to C 8 farad into 4 volt, this much coulombs. So it's a 32 coulombs. So option A is the correct answer. Question number 42 is told the mobility of free electrons in a conductor is directly proportional to the electron. Okay. So mobility is given as the drift velocity by the electric field, which is also given as E tau by m, which is charge into relaxation time by m by the mass. So therefore charge by mass ratio is always constant. So the mobility of free electrons is directly proportional to the relaxation time. So it means that option B is the correct answer. Variation of resistance of the conductor with temperature is as shown. Temperature coefficient of the conductor is, so here see, here the slope R versus T, so that R naught, so R equals to, we know, R naught into 1 plus alpha delta T, T minus T naught. So when T is equal to T naught, then R equals to R naught, and slope is how much? The slope is given as delta R by delta T. You can see it is R minus R naught. Since in this graph you can see this point is 0 comma R naught, this point is R comma T. Therefore this will be R minus, so this will be actually slope, no, this is sorry, this is okay, T comma R, okay, T comma R. This is R minus R naught by T. This is the slope. From here we say that R minus R naught, that is equal to R naught to alpha into T minus T naught. This point is T naught actually, okay, minus T naught. Therefore alpha R naught into alpha, that will be equal to R minus R naught by T minus T naught, which is the slope, which is equal to M. So this is M. So therefore alpha will be equal to M by R naught. So option D is the correct answer. Question number 44, it is told the potential difference between A and B in the following circuit is. So this is 6 volt, this is 4 volt. So therefore E equivalent is 6 minus 4 is 2 volt. R equivalent is 2 plus 8 ohm, that is, since 2 ohm and 8 ohm are connected in series, that is 10 ohm. Therefore the current through the circuit, that will be equal to E equivalent by R equivalent, that is 2 by 10, that is 0.2 ampere. Now therefore you can see here, this will from, so VA, if you apply KVL, so VA plus 4 volt current is flowing in the opposite direction like this. Current is flowing, this is 6 volt, this is 2, this is 4 volt, 8 ohm. Current is flowing like this. We are doing VA minus VB. So we are going in the opposite direction of the current flow. This will be VA so this will be VA plus 4 volt plus IR, that is 8 into I, that is 0. That is equal to VB. Therefore VB minus VA, that will be equal to 4 volts, so that is 4 plus which is 16, 1.6, that is equal to 5.6 volt. Option B is the correct answer. Then in question number 45, it is told that it is told in the following network, the potential at O is how much? So we can say, we have to apply KCL, which is the Kirchhoff's current law, which is called as the junction rule also, junction rule. So we can apply the rule, that is net current that is entering the junction will be equal to the net current which is exiting the junction, or we can say the sum of all currents entering the junction, that is equal to 0. Sum of all currents entering the junction, that is equal to 0. So here point O is a current junction, so therefore let us tell that we have to find the electric potential at the point O. So let the potential at the junction O, be equal to V. Therefore we can say that V minus VA by 2 ohm, that is that then plus, this is the current flowing, so V, or so the sum of all currents and entering or exiting, we can say going out of the junction, that is equal to 0. So here we can say that the current which is going away like this is suppose I1, this will be I2, this will be I3. So I1 will be how much? I1 will be V1 V minus VA by 2. I3 also will be equal to V minus VB by 4. I2 will be V minus VC by 2. I1 plus, simply we have to do I1 plus I2 plus I3, that should be equal to 0. So since we have to apply the sum of all currents going out of the junction, that should be equal to 0. This is V minus VB by 4, that then V minus VC by 2, that should be equal to 0. So therefore V minus 8 by 2 plus V minus 4 by 4 plus V minus VC, that is 2 by 2, that should be equal to 0. So therefore V by 2 minus 4 plus V by 4 minus 1 plus V by 2 minus 1, that is equal to 0. So therefore we can say V by 2, that is V by 2 plus V by 2, V by 2 plus V by 2 plus V by 4, that is equal to 1 plus 1 plus 4 plus 1 plus 4. Therefore V plus V by 4, that is 5V by 4, that is equal to 4 plus 2 6. So V equal to 6 into 4 by 5. 5 into 2 I can do, into 2 I can do. So this is for the stage of 48 by 10, that is equal to 4.8 volts. So option D is the correct answer. So hope you have understood the solutions of all these 45 questions. So in the next part of this video on current, electricity, we shall solve from the question number 46 onwards. So in these 45 questions, any step if you are unable to understand or any other doubts you have, then please write us in the comment section. We shall clarify them in the subsequent videos. And please install our Sapience Education application, where we shall upload some important homework questions on the previous year KCET exam. So here we shall end this part 2. Thank you everyone. Bye.